This is Jay. I'm a developer relation engineer working at Aptos Lab. And today I want to show you guys a template that can help you get started on building on Aptos. So first of all, let me give you guys an overview of this template. So at Aptos Labs, we build various kind of tools to help developers to building on Aptos. And some of the tools are like lower level, such as the SDK and indexer. And some of the tools are higher level, which is more like include these low level tools, and we aggregate them together, and we create this like ready to build template. So if you are joining a hackathon or want to build a full stack app on Aptos, we recommend you just start with the template instead of going into the docs and looking at each tool. So currently we have two templates at a high level. So one is this one that I'm showing here, Aptos full stack template. This one is maintained by myself, which is more opinionated and more battery included. So, and we have another one called Create Aptos Step, which I linked here. And that one gives you more template option and gives you like a vanilla template, and also gives you a full stack template. And you can also get to choose between the White and the Next.js framework. And you also get to choose what kind of contract you want to start with. So it provides like the token launchpad and NFT launchpad and several others. But for this template that I'm showing here, this is one that I would use because, it just have everything ready end to end, and it also gives you a nice example of what a truly end-to-end app would look like on Aptos. So let's go to the demo first to see what it does. So this contract, this template is pretty straightforward. So it just it has a message board stored on chain, and everyone can just create new message in the message board and also update the message created by them. And it also comes with, so this frontend is built with ShadCN and Next.js, and backend you can think of the backend is just on-chain contract, and we have an indexer in Rust that will monitor the chain and parse the on-chain events and store the data into a Postgres database. So the frontend can have a better performance when reading the data and more flexibility. Like you can see, we can sort the data by timestamp. You cannot do that by reading directly from the chain. And we also have the analytics dashboard to track the metrics for the user. And we also have a point system to simulate the point system in the normal DeFi app you would see. And so now let's create a new message. You also have the wallet connector set up. You can either connect the extension wallet like Petra, or you can connect the social login wallet like Aptos Connect, where you just use Google as your wallet. So now you can see the transaction has been broadcasted to the chain, and it's also sponsored. That means the user doesn't need to pay gas fee to create a message. So this is also a nice demo of what a gas list transaction will look like on Aptos. And you can see the front end automatically refresh the data. And we can see the message detail and also update the content. So this is a demo of the full stack template. And now let's jump into the code and break it down. So, and another thing is like, before we get started, if you are building on a Windows machine, or you're building this thing from a location where you have some network issue connecting the Aptos RPC, you can also choose to develop in GitHub Codespace, which is basically a remote server that you can do the development instead of your local machine. And we also have the guide for that and the video tutorial in English and Chinese. And it's all configured. You just create a code space and get started if you don't want to set up the environment locally. Yeah, so now let's break down the repo. At a high level, we have 4 parts. So usually when you try to build on Aptos, if you have a contract like on-chain logic, then we recommend people to start with this mu directory. And this directory will contain all the contracts for your app. And then once you have the contract ready, depends on the complexity of the app. Sometimes you would want an indexer. So when do we need an indexer? You usually need indexer when your data structure is pretty complex and it's very hard to read it on-chain. For example, in this message board example, you want to be able to sort the message by their creation time and also by their update time, and also filter by the message creator. It's pretty hard or like inefficient to do those operations on-chain. Instead, we can have an off-chain indexer that we usually run in Docker and host it on Google Cloud to parse the data and store them in a Web2 database like Postgres. And now the frontend can just read the database however it wants, just like a Web2 service, like performant and flexible. So depends on your need. You might have an indexer. And then we have the Next.js frontend. So this is using the latest feature in Next.js, like the app router and the server action. So it also has this very nice, like small backend built in, so you can do all the data fetching securely in the Next.js backend. And it also include all the wallet connector and basically all the stuff you're gonna need, like caching and things like that. And in the end, we have this Node script directory, which you can write some simple Node.js script for testing purpose. And at each directory, we have a detailed README explaining how to use it. All right, so now let's jump into the detail. Let me open VS Code. So we will start explaining things from the contract directory. So as you can see here, we already support like a multi-contract layout. If you have multiple contracts, you just add more directory under the contracts directory. But since this message board is pretty straightforward, it only has one contract. So we will start it with the mu.toml file. So if you are a Rust developer, then this is very similar to the cargo.toml file, which defines the name and address, like the contract address and dependency. Here's probably the first concept that might confuse you, because on Aptos we have the notion of package and module. So module is each .mu file is a module, like here message.mu. This is a module, and each package can have multiple module. It's like you can have another .mu file under the sources directory, for example, to host the utils function, and all of them together is a package, and every module in the package will share the same address. Yeah, but if you want to learn more, you can read the doc. But this is not super important, I would say. You don't need to fully understand it in order to start building. So now let's look at the contract detail. Let's first collapse everything. So I would say when we design a contract, it's very similar to how we design a Web2 like backend service. Like we define the data structure, we define the API endpoints, like the read API and the write API. Then we implement the API logic, how we write the data or how we read the data. So for the message board example, we have a very simple struct, like data structure, just called message. It has content, creator, and timestamp. And the reason we did not use we do not have a message board like map or array list type of data structure is because Aptos, like on high performance chain like Aptos and Solana and Sui, we tend to store data in a distributed manner. So we can easily parallelize things. That means when two users create a message at the same time, there won't be any lock. Like the users don't need to wait each other. Like we can process the two transactions in parallel. And the downside of that is when data is stored distributedly, it makes it more complex to read the data. That's why like indexer is more common on high performance chain like Aptos and Solana. Then since we need the indexer, so we also need to define the event. This event will be emitted when the write function are called. So the event is also pretty straightforward. It has a message struct and also the message object address. So here we want to briefly talk about what is an object on Aptos. So you can think of it as our Aptos' answer to like contract account or PDA in Solana context. It's like a container to store data because data is stored distributedly, right? So this object would be like a contract account that only store a single message. You could put more stuff into it, but in this case, each message object only store a message struct. Then we have the init function, init module. This function will be called when the contract is published for the first time. You can set up some permission stuff or like the initial config. And then we have the create message function. For this, you will first create an object and then get the signer of the object. So the signer here is exactly like the PDA signer in Solana. It's like once you have access to the signer, you can move data, like store data into the object. So if you think of this case, like if an object would hold money, like hold some token, then you need the signer of the object in order to send the money, transfer the money out. So then we create the message, and we move the message to the under the message object signer. So this will place the message data in the object. In the end, we emit an event. And for update, you can see we take the message object because this is stored distributedly, so the contract itself doesn't know where to get the message object. The frontend needs to pass the message object to it. And you may wonder, how do we pass this to the contract? From the frontend perspective or like the off-chain perspective, this is just like address, but with type check. So on the front end, you're actually passing an address, like the object address here, and the chain will check the message struct exists at this address. So it's just like an extra safety check. You can also write it as address tab, but then you probably need to do the check later inside the function. So now let's look at the implementation detail. So we first borrow the message struct from this address, right? Here you can see we convert the message object to the address. Then we borrow, it's a mutable borrow the message struct. Then we check the message creator is indeed the sender of the transaction. Then we do the update. Then we emit the event. And for the read function, it's kind of similar to the update function, but it's a mutable. It's an immutable borrow because read function, like view function here, cannot do any state change. Yeah, which immutable borrows the struct and returns the content. So this is what a basic move contract would look like. Then we also have some util function for testing. And we have the unit test in this file. And we also have a thing called a move script here. So move script is our answer to, Aptos' answer to what if you want to call multiple functions in a single transaction. So the move script is not published to the chain. It's just a script that you have locally. And you can run it and it will execute everything in the script in a single transaction. I know this is, in some cases, still not that convenient. So Aptos is also working on, I think it's already live. Aptos also have a feature called a dynamic script builder that you can achieve this, like do multiple function call in a single transaction, but in a purely front-end context. So you can just do that in TypeScript instead of you have to write move contract yourself. So now we have looked at the contract source code and the script and test. We have these files for you to deploy and upgrade the contract and running the move script and generate the API. So usually the flow is like you will first create an Aptos account on testnet if you don't have one. And then you're gonna deploy the contract to a testnet. And once you've done that, you can run some script to test it to make sure it's working. And then you can also run this script to run the unit test. And we also have the generate API file. This is for generating API for the front end. And we also have the upgrade. And think all of this stuff are in the README. Yeah, you can follow the README for a better explanation. So before we look at other stuff, let me mention one last thing on the smart contract. So we have let's look at this thing, this package.json file in the move directory. So here we have an integration test framework for the contract. We call this Aptos workspace. So if you have worked on Solana or EVM, then this is something similar to Hardhat or Foundry or the Create Solana dApp that you use. So this lets you to do end-to-end test in TypeScript. And we can find the example here. You can see this will publish the contract to a local net that's running on your machine. Yeah, it depends on where you run it. If you run this whole thing in GitHub codespace, the local net will run in the GitHub codespace. But the point is that this local net is like it's not persistent. Like it only exists when you run this test, and it will be reset when you run it next time. So it just lets you do end-to-end test. You can call multiple functions and do some read operations, see if the data is what you expect, if it is what you expect. Okay, so that's everything for the smart contract. So now let's move to the front end and take a look at how the front end code is working. So as usual, we will start with the package.json file and look at the dependency. You can see we have the Aptos wallet adapter and the TypeScript SDK and a bunch of UI dependency from Redux UI because we're using ShadCN, which use Redux UI under the hood. And we also have this next PWA library. So this template is also PWA ready. And we have the Surf library from Sala Labs. So this provides type safety based on the contract API for our frontend. So if you want to learn more, you can also refer to the README. Here it teaches you some best practice on how to create a read-only user in the database. Since I think the special thing about the indexer database here is like it would only the indexer is able to write to it. The frontend can only read from it. So the frontend will never write to the database. Like all the write operation happen on chain, and the frontend just read the indexer database. So creating a read-only user makes it safer. And we also have some SQL query for you to like check the permission and the schema stuff. But we'll cover more on the indexer and database in a separate video. Okay, so let's, as usual, since this is a app router Next.js project, we start from the layout.tsx. So in the layout, we usually set the providers. Here you can see we have the theme provider, the query provider. This will support caching, and the wallet provider. And inside we have the header and footer and the toaster for toast and some alert for run network. And children here is the actual content of the page, which maps to here the page.tsx file. So before we look into the page content, let's take a look at the wallet provider first. So for the wallet provider, you can see it returns the Aptos wallet adapter provider from the Aptos library. And you get to choose which wallet you want to display. Continue with Google means Aptos Connect, where you can just log in with Google. And we have some other extension wallet. And we also have this Mizu wallet, which is a Telegram wallet. But since Telegram banned all other chain except Tau, now this is kind of deprecated. So now let's go to the page.tsx to see what the this decides what the page would actually look like. So now let's also look at the frontend demo. You can see this part is a header, and this is the message board. This is the create new message form, and in the bottom we have the footer. So let's first look at the message board. This shows you how to read the data. So it's a simple card component from ShadCN. You can read more about ShadCN from their document. So the title is a message board, which is this, and the content is the card content is a data table. So it takes a column that's defined in this file. So this is a standard format from what a data table would look like from ShadCN. So it has columns where you have the content, the timestamp, and the action, which are the columns here. And then you have the data table component, which will read the data from the server. So that means like a Node.js server that's running in the Next.js backend. So if we click into that, you can see it's in the actions.ts file and has the use server keyword on top. It means everything here are server actions. That means everything here is like you cannot access the stuff from the front end. So here you can securely use the API key from the environment variable, which is only accessible in the backend. Okay, so now let's also take a look at the environment variable. So everything that has started with this next public is public environment variable. That means they are visible on the front end. But everything without the next public keyword are private environment variable. That means those are only available on the backend. That means the server action or the API routes. But here we're not using API routes. I find server action is a much easier tool to use here. So yeah, so we have the get messages on server function. This will run a SQL query and get a message from the database messages table, which is a pretty standard Web 2 operation. So once you have the data, then it's just standard pagination, and we also have some caching here, as we can see. And in the end, we just display the table like this. So now let's take a look at the right part, which is this create message component. So here, again, it's pretty similar to how a form would look like in Web 2. But we have this account and send transaction function from the wallet hook. So when the user clicks the create button, it will trigger the onSend and submit transaction. We will call this function. So here we would first build the transaction. Because this is using fee payer, so we have to build the transaction and sign it like more manually, because Surf, the type-gen tool, doesn't support the sponsor transaction at the moment. So we first build the transaction, set the sender, which is the connected wallet, and set the with fee pair flag to true, and set the data like which function we want to call, and what's the argument passed to the function. And in the end, we also need to set the max gas amount. This is required for the sponsor transaction. And then we call the sign transaction. This will prompt the user to sign. So like this flow. So after that, after user sign, you will send the sign transaction to the backend, call this sponsor transaction on server function. Here you can see we do some deserialization and have the sponsor, the account that's paying the gas fee, sign the transaction as well. So we first load the sponsor account from the private key stored in the environment variable. So in production, you can probably also read it from Google Secret Manager if you don't want to store it in an environment variable in Vercel. And you have the sponsor also signed. And in the end, after both the sponsor and the user have signed, you can broadcast the transaction. And then back to the front end, it will wait for it to confirm and display the toast. Say a transaction is already broadcasted and sponsored. So that's the write flow. Let's also take a look at the update. So for update, it's similar to create message, but the difference is like, since it's not sponsor transaction, just a normal transaction, we get to use the type-gen tool from Surf. Once we load the API, once we pass the API to the wallet client from Surf hook, we get to call the function, and we can also see the type here. So remember the update message function we have in the front end, in the contract, like we're calling it right now. So we're calling this function right now, and as you can see, we never need to pass the sender explicitly. We just pass the argument after the sender. So passing these two arguments, as you can see, the object in front end, we just pass the address, then pass the new content. Then again, like wait for it to confirm. Like Aptos transaction confirm pretty fast. I think it just confirm in like one block. And that's it, I think. This covers how the front end would work. And I think in next video, I will talk about how the indexer would work. And if you have more questions on how to use the template or just anything related to building on Aptos, feel free to open a thread in this forum. So we have this thing for people to ask questions, for developers to ask questions and chat with us. We also like monitor this like on a daily basis. Or if you want to talk to me, you can also DM me on Twitter. My handle is 0xaptosj. So that's it for this video, and I'll see you guys next time.